Okay guys, so what we're going to be talking about here is we are going to be talking about our algebra review. These are ideas that show up a fair amount on the AP test that we need to know, but this is not like a comprehensive review of everything that we do in algebra, just a few ideas that show up fairly often. The first thing that we do need to talk about that shows up a decent amount on the AP test is what an exponent is. An exponent is one of three things. And they appear differently, I guess is what I should say. They all mean the same thing. You're all raising something to a power. But if we just have a positive exponent, and that's just like a whole number exponent, that just represents repeated multiplication. And we'll look at some examples of that in just a second. If we have a rational exponent, that represents both a positive exponent, like we talked about previously, and a root at the same time. And again, we'll do an example of one of those, and we'll go over that a little bit more thoroughly in just a second. The third thing that we need to talk about is a negative exponent, because those do appear a fair amount too. That represents repeated multiplication, but it means it's happening on the other side of the fraction bar, okay? And so here's, just as you're well aware, or hopefully you're well aware, if you saw something like 2 to the third, really what that's saying is I have 2 times 2 times 2. It's just repeated multiplication. 7 squared would be 7 times 7. 5 to the fourth would just be 5 multiplied by itself 4 times. This is the type of exponent that most people are familiar with. This is the type of exponent that most people don't have a problem with. It's when, and I've got memes down in the bottom, but I think my face is covering them, so don't worry about seeing those too much. But where we have an issue is when we have a rational exponent. This is where it starts getting more difficult, because what a rational exponent is doing is it's asking you to do two things at once. Or rather, to do two things. Not necessarily at once, but do one and then the other. When you have a rational exponent, that just means it's a fraction. So like 2/3 would be an example of a rational exponent. What that's saying is it wants us to, first of all, take the root of the number, it would be the third root, and it's always the number that's on the bottom. So for example, if I had like 27 to the 2/3 power, that is saying, first of all, that I need to find the cubed root of 27. And in this case, that would be 3. Now, technically, you could do this in any order. Technically, I could do the next step first, and it wouldn't matter, but it's easier to do the root before we do the number on top, which is technically just saying, okay, that's the exponent in this problem. So if that's the exponent, I would say now, I've got 3 squared, which is 9. So every one of these problems has 2 steps to it. The number on the bottom is saying take that root power, and then the number on top is saying raise that new number you get to whatever that exponent is. So here's another example. I'm only going to do one of these, just in the interest of time, so I think you understand it. If I had something like 27 to the 4/3 power, what that is saying is, first of all, I need to take the cubed root of 27. That's saying what times itself 3 times gives us 27? That would be 3. Once I find that number, then it's saying I'm going to raise that to the 4th power, because that's the number that's on top of the exponent. So 3 to the 4th would be 81. That's 3 times 3 times 3 times 3. The other examples, if you're dying to know the answer, the example to the top problem is 4, and the example to the bottom problem is 125, if you want to work those out on your own. Okay? Here's another one. Okay? Another thing that shows up a decent amount on the AP test is a negative exponent. Now, I think most people understand that a negative exponent means that you move whatever it is to the other side of the fraction bar and it becomes a positive number. But where I see the issues are on problems like this, where I've got something like 3x to the negative 2, and then I have parentheses 3x to the negative 2. You have to be careful about what you move, because in this first example, only x is being raised to the negative 2 power. So what I have here is really 3 over x squared. Whereas in the second example, what we have is everything is being raised to the negative 2 power, which means everything is going to the other side of the fraction bar. So now I would have 1 over 3x squared. I realize they're fairly subtle, but you have to watch for parentheses when you're dealing with negative exponents. Like, for example, this other example, this would just be x to the 4th divided by 2, because only the x is being raised to the negative 4th power. Whereas in this one, where both the 2 and the x are being raised to the negative 4th, all of that would go to the top, and that would be the answer to that particular problem. Now, I know that most of us know how to solve an equation. We know solving an equation means that we're going to find the number or numbers, then when I insert them for a variable, it makes it so that one side, everything that's on one side of an equal sign, is equivalent to something that's on the other side of the equal sign. And so another thing that when it comes to solving equations that we do fairly often is we factor. Now, a lot of times people are like, why do we factor? Because all we're doing technically when we factor is rewriting something in a different form. And usually what we're doing is we're taking something that was only adding before and introducing multiplication into that problem. The type of problems that you guys have seen most often are ones like these where we're trying to factor a trinomial. The hard part is I can't just look at any of these equations and say, oh, I know what the answer to that problem is. So what we do is we factor a trinomial. Now, anytime we're factoring a trinomial, or anything, honestly, that has both x squared and x in it, never ever, one mistake I see fairly often is I'll see a problem like this where it says x squared plus 2x equals 0. And the first step I'll see everybody do is subtract 2x over to the other side. Whenever you have an equation that has variables raised to different powers, you need to move everything to the same side and factor it almost immediately, pretty much, is the way that you should do that. So that's just a brief aside. So what we do here is we say, okay, and you guys know how to factor. This is just a brief review. In these problems, you put x at the first of both of the parentheses, because that's the variable. And then you ask yourself, what two numbers multiply together to give us -3 that add together to give us the number that is in front of the x? And there is one extra step that we have to do sometimes, and we'll talk about that in just a second. In this case, hopefully you can see that is both 3 and -1. So we take those numbers and we put them in the parentheses, and what we've done is now made this problem easier to see what the solutions to this equation would be. Hopefully you can see that it would be -3 and +1. If the number in front of x squared is not a 1, in other words, it's not just x squared there, we can still use the same process. The only difference is we have to multiply those two numbers together. So I multiply 2 and 3 together, and that gives me the number on the outside. Everything else actually stays pretty much the same as far as steps go, other than there's one additional thing we have to do at the end. We'll talk about that in just a second. So now we see what two numbers multiply together to give us 6, that add together to give us +5. Hopefully you can see that that is 3 and 2. So I put 3 and 2 in those boxes. And then the last step in these problems, and I don't want to go into it too much because technically you're doing something that's slightly mathematically incorrect, but it still gives you the right answer. The last thing you do is once you get to this point, you divide both of those numbers that you got by the number that's in front of x squared. If it reduces down, like I've got 2 over 2 here, then I could say that that is x plus 1. And then if it doesn't divide down, then I just leave it as 3/2. And then we can see in this problem, two answers that would make this statement true, or make this equation true, would be -3/2 and -1. So hopefully that kind of makes sense as a brief review of factoring trinomials. A couple of things that you don't have to worry about in this class. It's actually pretty nice. The first thing you do not ever have to worry about is I've never seen the quadratic formula used on the AP exam in 15 years. I can't ever say that they won't, but I've never seen it. I'm guessing that's not something they're going to test you on. The other thing is, we talked about this previously, we don't worry about imaginary numbers in this class, so you don't have to worry about getting imaginary solutions. If you get the square root of a negative number, you just say, oh, that is not an answer. All right, the last thing we need to talk about is solving equations with rational exponents. And you can see the 3 steps there. If you need to take a second to write those down, just pause the video and then come back. And we'll look at an equation, and we're going to look how to solve equations like these. What we do, the steps that we follow is, first of all, even though it's x to the 3/2 power, we still treat it like it's just x. We want to isolate it. So in this case, I'm going to divide both sides, by 3. So here I get x to the 3/2 is equal to 27. Now, I want x by itself, but exponents have slightly different rules. We can't divide by anything. We can't multiply by anything. But one thing we can do to both sides is we can take both sides to the reciprocal power. Okay, so if the exponent right now is 3/2, I'm going to take both sides to the 2/3 power. So 2/3, 2/3. What that does is there are rules of exponents when we have something like this that I can multiply those two exponents together, and it's not something you necessarily need to know, but it basically makes the rational exponent go away. We talked about 27 to the 2/3 earlier. We found out that the answer to that was 9 because we can evaluate it. So those are the 3 steps. First step, isolate the x. So on this last problem, I would have to minus 4 from both sides. So then I get x to the negative 1/2 is equal to 9. Step number 2 is we raise both sides to the reciprocal power. So the reciprocal is just that number flipped upside down. Don't change the sign. In this case, it's a negative number, so I raise both sides to the negative 2. That gives us x on one side, and then I've got 9 to the negative 2. Remember, that means that the exponent is really taking place on the other side of the fraction bar. So what I have is 1 over 9 squared. Then I get x is equal to 1 over 81. These are all examples of algebra. Now, they're not tricks. None of these are tricks, but these are the things that show up the most on the AP exam when it comes to using algebra. There are other things that we'll talk about later in the class, particularly trigonometry, that you're going to need to know as you progress further in the class. Anyway, guys, that is the video for Algebra Review. If you have any questions, come on in.